Hello friends, continuing with the instructional videos on this inverter. In previous sessions we learned how to start the motor from the keypad, set the frequency from the keypad, set the frequency from the analog voltage input, and how to set the start and stop. In this video we want to learn together how to set the frequency using the 4 to 20 milliamp analog current input. In the S100 inverter, we mentioned that if we want to start the motor from the keypad, we need to set the DRV parameter in the basic group to 0, which means keypad. But if we want to set the frequency reference to 4 to 20 milliamps, meaning the analog current input, we need to set the FRQ parameter in the basic group, which is the operation group, to number 5, which means I2. So, if we want to use the analog current inputs, for example, a pressure sensor that outputs 4 to 20 milliamps, and we want to connect this pressure sensor to the inverter, we need to set our FRQ parameter to number 5, which is the analog current input of 4 to 20 milliamps. For example, if we want to connect a 2-wire pressure sensor that outputs 4 to 20 milliamps to the inverter, we need to connect the sensor's output to the I2 terminal and its positive terminal, source, to the inverter's 24-volt power supply. If we have a controller with a 4 to 20 milliamp output and its own power supply, and we want to connect it to the inverter, we should connect the controller's output to the I2 terminal and the controller's negative to the CM terminal. In this case, since the 2-wire sensor doesn't have its own power supply, we connect its output to I2 and its source to the inverter's 24-volt terminal. For analog current inputs, just like analog voltage inputs, 0 to 10 volts, we need to define 2 points for the inverter. Those points are parameters 53 and 54, minimum current and minimum frequency, and parameters 55 and 56, maximum current and maximum frequency. We need to specify, for example, at the lowest value, at 4 milliamps, what the frequency should be, and in parameter 55, at 20 milliamps, what the frequency should be. Now let's put into practice the settings we've learned together and test the analog current input and output. As we mentioned, if we want to provide a frequency reference to the inverter using a 4 to 20 milliamp analog current input, like a 2-wire 4 to 20 milliamp sensor, we need to set the frequency reference to 4 to 20 milliamps. To do this, we should set the FRQ parameter in the main group to value 5. So, we go to the FRQ parameter, enter it, set it to 5, and confirm. As for DRB, we said that if we want to start from the keypad, it should remain at 0, which it is, so we confirm that and go back. Here, I have a signal generator here, which gives me a 4 to 20 milliamp output. I want to connect the output of this signal generator to the current analog input of this inverter. Well, since my signal generator here is self-powered, I need to connect it to the I2 and CM terminals. I connect the output of the signal generator to the I2 terminal. After connecting the output of my signal generator to I2, I connect the negative terminal of the signal generator to the CM terminal of the inverter. Well, after I have completely finished the wiring process, now if I proceed to change the output value of this particular signal generator, which is specifically designed to output a current range of 4 to 20 milliamps, the corresponding frequency value displayed on the inverter keypad should also accurately and precisely change. You can clearly observe that as I gradually increase the milliamp output from the signal generator, the frequency output on the inverter also consistently changes in response. For example, if I carefully increase it now, you can distinctly see that at a precise reading of 15 milliamps, it prominently displays the numerical value of 33. Conversely, if I then proceed to decrease it, you can readily observe that the frequency value also steadily decreases accordingly. So here we have meticulously set the FRQ setting to 5, which specifically signifies that the analog current input is indeed 4 to 20 milliamps, and we have diligently completed our wiring connections to the I2 and CM terminals, ensuring proper functionality and operation.